Welcome to Pratham Science Academy classes. And in this video, we are going to solve uh, maths question paper that is of 2023 and set 1 of code 311. And let's get started with the first section, which primarily consists of MCQs. So this is our first section, A of multiple choice questions, and each question is of 1 marks each. So our first question is the graph of polynomial, the graph y is equal to px. Let's say, so this is a polynomial function and graph of this polynomial p of x is given. We have to find the number of zeros from the graph, and we know that the number of zeros is actually the number of points at which this graph intersects the x-axis. So there is only one point where this graph intersects the x-axis. So correct answer for this is option B, which is 1. Now, for second MCQ, we have to find the value of k for which the pair of equations. So let's write down the pair of equations. The pair of equations are kx is equal to y plus 2. So this is now kx minus y minus 2 is equal to 0. And next is 6x is equal to 2y plus 3. So this is 6x minus 2y minus 3 is equal to 0. Okay, so these are our two pair of equations. Okay, now it's given that this pair has infinitely many solutions. So in this case, our A1 is k, B1 is -1, C1 is -2, A2 is equal to 6, B2 is equal to -2, and C2 is equal to -3. Now, for infinitely many solutions, we know that the condition is A1 upon B1 for infinitely many solutions. So for infinitely many solutions, here A1 upon A2 is equal to k by 6, and B1 upon B2 is equal to -1 by -2, which is 1 by 2, and C1 upon C2 is equal to -2 by -3. Now, for infinitely many solutions, the condition is A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. And putting the respective values gives us A1 upon A2 is equal to k by 6, B1 upon B2 is equal to 1 by 2, and C1 upon C2 is equal to 2 by 3. So we have to find the value of k, but in this case, 1 by 2 is not equal to 2 by 3. So that means these pair of equations are not the valid equations for infinitely many solutions. It has to be all the pairs should be equal. So should be equal. All these ratios should be equal, but we have to find the value of k, but before we find out the value of k, it's b1 upon b2 is not equal to c1 upon c2. So that means this condition has failed here. So there is no value of k for which, even if we put any value of k here, this will not be the case for infinitely many solutions, and this condition has failed here. So our answer for this is it does not exist. Okay, now let's move on to question number 3, where it's given that p minus 1, p plus 1, and q plus 3, these terms are in AP. So if these terms are in AP, that means that common difference should be same. So that means if I subtract p plus 1, p minus 1 from p plus 1, so our d is, that is the common difference, p plus 1 minus p minus 1. This should give us d. And if I subtract this, p plus 1 from 2 plus 3, this should also give me d. So that means this is also d and this is also d, and it should be equal. So let me open up the bracket now, which will give us 2 plus 3 minus p minus 1. So p and p gets cancelled, it's equal to 2, and it's 2p minus p is p, 3 minus 1 is 2, 2 and 2 gets cancelled, so p is 0. So the value of P is 0 for which these terms should be in AP. So correct answer is option C. Okay, now for question number 4, it's given that we have to find the ratio in which the x-axis divides the line segment joining the points. And so we know that if x-axis divides a line segment joining some points, then the point at which this line intersects the x-axis has the coordinates x comma 0. So let's try to get a rough sketch for this. So there, let's say this is the x-axis and it's dividing the line segment joining the points. Let's say we have this point A here, 3 comma 6, and B is minus 12 comma minus 3. Now the line joining these points, this is, let's say, our x-axis is intersected here, and the point of intersection lies on x-axis. So this is x comma 0. But we have to find the ratio. So let's say the ratio is k is to 1. Now we know the section formula. Let's write down the section formula. The section formula gives us the coordinates of the point, that is the point P, and the section formula is m1 into x2 plus m2 into x1 upon m1 plus m2 comma, this is m1 into y2 plus m2 into y1 upon m1 plus m. Okay, so x comma y is this point, so it's x comma 0, and m1 we have assumed that the ratio is k is to 1, so m1 is k, and x2, let's say the x2 is negative 12, so this is negative 12, m2 is 1, and x1 is 3. M1 plus M2 is K plus 1. Now M1 is K, Y2 is, this is negative 3, so this is negative 3 plus M2 is 1 into Y1. So Y1 is 6 upon K plus 1. So this is now equal to x comma 0 is equal to negative 12k plus 3 upon k plus 1, and negative 3k plus 6 upon k plus 1. We have to find the value of k. So let me equate the ordinates. So 0 is equal to minus 3k plus 6 upon k plus 1, and this is now 0 if we cross multiply. So minus 3k plus 6 is equal to 0, minus 3k is equal to negative 6, and k is equal to 2. So k is equal to 2 means the ratio is 2 is to 1, and our option for this is option D is the correct answer. Let's move on to the next page. Okay, so for the next page, our question is question number 5. So in this given figure, this PQ is a tangent to the circle. This is which is centered at O. So O is the center of the circle, and the central angle is AOB is equal to 95. We have to find the measure of angle ABQ. So this is what is supposed to be find out. Okay, so let's try this. Let's draw this right. That the triangle in the middle. Now OA and OB are equal because these are the radii of the same circle. So angle AOB is 90 degree. Now OA is equal to OB. They are the radii of same circle. And these radii with the chord AB, they form the triangle. So angle opposite to the equal sides are equal. So angle AOB is equal to angle OBA because angles opposite to equal sides are equal. And if you use the angle sum property here, this is angle AOB plus angle OAB plus angle OVA is equal to 180 degree. This is because of the angle sum property of triangle. Now we know angle AOB is 95 degree. These two angles are equal, so I'm just going to replace them with going to replace OAB with OBA. So instead of OAB, I'm going to put OBA because they are equal, plus angle OBA is equal to 180 degree. Now this is 2 times angle OBA is equal to 180 minus 95, and 180 minus 95 is 5 and 85. So angle OBA is equal to divided by 2, which is equal to 4 7 14.5. The angle OBA is 47.5 degree. Now this angle OBQ is 90 degree. Angle OBQ is equal to 90 degree because radius is perpendicular to tangent at point of contact. Now OBQ it is made up of two angles, angle OBA and ABQ. So this is angle OBA is can be broken down into angle OBA plus angle ABQ plus angle ABQ is equal to 90 degree. Now OBA is 47.5 degree plus angle ABQ is equal to 90 degree. And let's subtract this from 90 minus 47.5 degrees. So 10 minus 5 is 5. And it's 90. So this is 2. And 42.5 degrees should be our answer. So the correct option is option B. Okay, moving on to question number 6. Let me raise this. Okay, for question number 6, it's given that 2 tan A is equal to 3, and we have to evaluate the value of the given trigonometric expression. So 2 tan A is equal to 3. We are on to question number 6, which gives us tan A is equal to 3 by 2, and tan A in terms of sine and cos A is sine A by cos A. So let's consider that sine A be 3x and cos A be 2x. This is so let's evaluate now. This is 4 into sine A plus 3 into cos A upon 4 sine A minus 3 cos A. So 4 sine A is 4 into 3x plus 3 cos A is 3 into 2x upon 4 into sine A is 3x minus 3 into cos A is 2x. So this is 12x plus 6x upon 12x minus 6x, which is equal to 6x. Sorry, it's 18x. 12 plus 6 is 18x. It's 6x. X and S gets cancelled, and answer is 3. So correct option is option C. Okay, so we are done with question number 6 and moving on to question number 7, which is based on the second chapter. Okay, so it's given that alpha and beta are the zeros of the polynomial. Let me write down the polynomial. So polynomial is p of x is equal to x squared plus x minus 1. And let's write down the respective coefficients of x squared, x and 1. So x, a is 1, b is 1, and c is equal to negative 1. Now, it's given that alpha and beta are zeros. So alpha and beta are zeros. Let's write down the sum of the zeros, which is given by b minus b by a. So this is minus 1. And alpha beta is the part of the zeros, which is c by a, which is negative 1. We have to find 1 upon alpha plus 1 upon beta. Let's take the LCM, which gives us beta plus alpha. So beta plus alpha is negative 1, alpha beta is negative 1, which gives us the answer 1. So A is the correct option. Okay, now moving on to question number 8. We have to find the least value of the A for which the quadratic equation has rational roots. Now, Our given quadratic equation is 2x squared plus kx minus 4 is equal to 0, and a is equal to 2, b is equal to k, and c is equal to minus 4 now. So this quadratic equation has rational roots. What does it mean? So we know that the root of the quadratic equation is given by minus b plus minus root of, if you use the quadratic formula, this is b square minus 4ac upon 2a. And let me put in the respective values, which is minus k plus root of b square k square minus 4 into a, which is 2 into negative 4 by 2a. So this is now x is equal to minus k plus minus root of k square plus 4 to the 8, 8 4s are 4 to the 8, and 8 4s are is 32 upon 2 into a is 2 with, so this should be 4. Now, this whole expression will be a rational number if this is a perfect square. That is k squared plus 32 is a perfect square, because we have to get k squared plus 32 out of the square root, and once the number is in the square root, it should be a perfect square so that it comes out of the square root. And once we have a rational number out from this square root value, so this whole will be, the zeros will be the rational numbers. Okay, now we are more concentrated on square plus 32, so it should be a rational number, that is a perfect square. And if I put k is equal to 0, this gives me the value 32, which is not a perfect square. Now if I put k is equal to 1, that is 1 square plus 32 is equal to 33, which is also not a perfect square. If I put k is equal to 2, this is 2 square plus 32, which is equal to 4 plus 32 is equal to 36. Now this is a perfect square because square root of 36 will give us 6. So the least value of k for which this quadratic equation has rational roots is 2. So this is 2, and our correct option is option B. Okay, moving on to question number 9. Let me erase this. So, okay, so for question number 9, we have to evaluate 3 by 4, 10 square 30 degree minus secant square 45 degree plus sine square 60. Okay, we have to replace the values of, now tan 30 is 1 by root 3, so it's squared, so it's square. Now secant 45 is 2 square, and sine 60 is root 3 by 2 the whole square. So this is now 3 by 4 into 1 by 3 minus 2 plus 3 by 4. So this is now 1 by 4 minus 2 plus 3 by 4. So 1 by 4 plus 3 by 4 is 4 by 4, which is 1. So it's 1 minus 2, and the value is negative 1. So option A is the correct answer for this. Moving on to question number 10. Okay, for question number 10, it's given that the curved surface area of a cylinder of height 5 centimeter. So it's given that the curved surface area is 94.2 centimeters square. So curved surface area's formula is 2 pi RH, which is equal to 94.2, and it's 2 pi into radius. We have to find out the height is 5. This is 94.2. Now R is equal to 94.2 upon 2 pi into 5. And it's given that the value of pi is 3.14. So this is 94.2 into 2 into 3.14 into 5. Okay, so this is 2 4s are 8, 7 are 14.1. This is 47.1 upon 3.14 into 5. And this can be written as, if I multiply them with 100, So this is 4710, and this is 314 into 5. So this gets cancelled, and it's 15, and it's 5, that is 15. So this is 3. So our option is option 3. Again, now let's move on to the next page and try to solve these questions. Okay, so for question number 11, we are given with the distribution below, which gives the marks of 80 students in a test. And this is a less than graph with the information, and we have to find the model class of the distribution, and the model class of the distribution is the one with the highest frequency. So let's get this converted into the class intervals. The first class interval is less than 10, which is 0 to 10. The next one would be 10 to 20, then 20 to 30, 30 to 40, and 40 to 50, and then 50 to 60. Okay, now let's find out the frequency. And for 0 to 10, less than 10, the frequency is 3. But for 10 to 20, the frequency is not 12 because this frequency is for less than 20. So for less than 20, we have 12 observations. And among these 12 observations, we have 3 that are less than 10. So for between 10 and 20, we have 9. So we have to subtract this. 12 minus 3 is 9. 27 minus 12 is 15. 57 minus 27 is 30. 75 minus 57 is 8, 18. So 15 minus 7 is 8. 80 minus 75 is 5. Okay, so the class with the highest frequency is the model class, and which is 30. And let's move on to question number 12. So for question number 12, it's given the curved surface area of a cone has to be evaluated, and the height of the cone. So the height of the cone is 24 centimeters. So height is equal to 24 centimeter, and radius is equal to 7 centimeter. Now the curved surface area of the cone we all know is given by pi into r into L. Pi is 22 by 7. We are going to take 22 by 7 because the radius is 7, so this gets cancelled with 7. Now L square is equal to h square plus r square, and L is equal to under root of h square plus r square, so this is under root h square plus r square. So this is 22 into under root h. Height is 24 cos square, 24 square, and radius is 7 square. So 24 square is 576, 7 square is 579, which will give us 6 under root 625, and 22 into 25 is 550 centimeter square. So C is the correct option. We can now let's move on to find the distance between the points. So distance between 2 points is given by the distance formula. So let's say these coordinates are x1, y1, x2, y2. And we know that the distance between the points is given by x2 minus x1 the whole square plus y2 minus y1 the whole square. So x2 is minus 2 root 5 minus 0 the whole square, and y2 is 0 minus y1, which is 2 root 5 the whole square. This whole thing is under root. So this is minus 2 root 5 the whole square plus minus 2 root 5 the whole square. Okay, so this is 2, it's 20, and 20, which is under root 40, and under root 40 is 4 into 10. So this can be written as 4 into 10, and root of 4 is 2, so this is 2 root 10 units. So 2 root 10 units, the option A. Okay, for the 14th, we have to find the quadratic polynomial which has the zeros. So our zeros are, let's say, alpha is equal to minus 2 by 3 and beta is equal to 2 by 3. So quadratic polynomial is given by x square minus sum of zeros into x plus product. So sum of zeros is minus 2 by 3 plus 2 by 3 into x, and product of zeros is negative 2 by 3 into 2 by 3, so this gets cancelled, and this is x square minus, so this is 0, and we have minus 4 by 9, so this can be written as 9x square minus 4 is the polynomial. And if we check the given options, so this is not 9x square minus 4, this is not the one, it's not the one. This can be the one which has y, which is a constant. So our option, correct option is option B. Okay, for 15th question is given that value of each observation of statistical data is increased by 3, then the new mean will remain unchanged, increases by 3, increases by 6, or increases by 3. Okay. Now we know that the mean of data is given by sigma fi into xi by sigma fi. This is question number 15. And xi is the observation. So new observation is now 3 times the old observation. This is the new observation. So new mean would be sigma fi, and observation is 3 times old observation by sigma fi. So 3 is constant, it's out. So this is 3 sigma fi by fi, and this is mean. So new mean is 3 times the old mean. So it increases by 3 is the correct option. Okay, for question number 16, it's given that what is the probability of happening an event? So let's say the probability of happening an event is P, and probability of non-happening of the events, that is probability of not P is equal to Q. So what is the relation between P and Q? So we know that probability of P plus probability of E naught is equal to 1. So probability of E is P, probability of E naught is Q. So relation is P plus Q is equal to 1. So P plus Q is equal to 1 is the correct option, which is option A. And let's move on to the next page. Next page. For question number 17, uh, it's given that the probability of winning the first prize in a lottery is 0.08. So this is the probability of winning, which is 0.08. Now, the total number of tickets sold, uh, number of tickets sold is equal to 6,000. Now, how do we find the probability? This is the probability of winning should be the total tickets sold, and it has to be it has to be number of tickets she bought. So number of tickets she bought has to be divided by total tickets sold, and that should give us the probability. Now, number of tickets sold, or number of tickets she bought, let it be n, and number of tickets sold are 6,000, and we have to find the number of tickets she bought. So this is equal to n is equal to 0.08 into 6,000, which is 6 A's are is 40,000, and this gets cancelled, so this is 480. So 480 is the correct answer for 17. And for question number 18, we have to find in a group of 20 people, 5 can swim. So total people are 20, and number of people who can swim are 5. Number of people who can't swim are 5. Now it's asked to find the probability that he or she can swim. So we have to find the number of people who can swim is equal to 20 minus 5 is equal to 15. And the probability who can swim is equal to number of people who can swim divided by the total people, that is 20. So this is 3 by 4. And 3 by 4. So option A is the correct answer. And the next one is assertion and reasoning type questions. So the first one is the point 0 comma 2 coordinates 0 2 is the point of intersection of y-axis with the line. We have to check whether it's a point of intersection with the given line. And the given line is 3x plus 2y is equal to 4. Now, if P is the point of intersection of y-axis, so this is the point on the y-axis, so that means it should satisfy this equation. So if I put this point is 0, comma 2 in the LHS, so this is 3 into 0 plus 2 into y, which is 2 is equal to 4, which is equal to RHS. So this point satisfies the given equation. So that means assertion is true. So this is the point of intersection of y-axis with the line. The distance of point 2, 0, comma 2 from x-axis. So 0, comma 2 is on the y-axis and its distance from the x-axis is 2. So ordinate gives the distance from the x-axis, which is 2. So both of these are true. So both assertion and reason are true, but reason R is not the correct explanation of assertion A, so B is the correct option here. Okay, now for question number 20, the perimeter of triangle ABC is a rational number. So let's find out the perimeter is a right angle triangle. So the hypotenuse is square of these, sum of the square of these two sides, which is root 4 plus 9, which is 13. And now the perimeter is 2 plus 3 plus root 13. So this is 5 plus root 13 is the perimeter, and root 13 is not a rational number. So this is the perimeter of a triangle ABC is a rational number is false. Now the sum of the squares of two rational is always a rational number. That's true, because the sum of the squares of two rational numbers is always a rational number, with this is true. So assertion is false, but reason R is true. So option D is the correct answer for question number 20. And let's move on to the next page. Okay, so we are in section B, and this section comprises of very short answer type questions, and every question is of 2 marks each. Okay, so the first one is we have to solve the pair of equations x is equal to 3 and y is equal to minus 4 graphically. So let's sketch its graph. And so let's say this is our plane with x and y axis. This is x axis, this is y. Now x is equal to 3 is a line which is parallel to y axis. So this is x is equal to 3. Okay, x is equal to 3. And the next one is y is equal to negative 4. So negative 4, let's say it's negative 1, negative 2, negative 3, and negative 4. So this is the graph of y is equal to negative 4, which is parallel to x-axis. And now both these lines intersect at 3, 4. So this both of these lines are intersecting at 3 comma minus 4. So the solution of this graph is x is equal to 3 and y is equal to negative 4. Okay, for part B, we using the graphical method, we have to find whether the system of linear equations is consistent or not. and we have to plot the graph of x is equal to 0 and y is equal to -7. So let's plot the graph. So this is, let's say, x and y axis. Now x is equal to 0. So this is the origin, x and y axis. So x is equal to 0 is here. And we know that when we plot the graph for x is equal to 3, it's a line parallel to y-axis. Now x is equal to 0, we have to plot a line parallel to y-axis at 0. So this is actually the y-axis. So x is equal to 0 is your y-axis. Now the y is equal to -7 is a line parallel to x-axis. So let's say it's -1, -2, -3, 4, 5, 6, and 7. So y is equal to -7 is a line parallel to x-axis. Let's say this is parallel to x-axis. So y is equal to -7. Now this is x is equal to 0 and this is y is equal to -7. Both of them are intersecting at -0, comma, both of them, the point of intersection are 0, comma, -7. That is the point of y-axis. And x is y is equal to -7. Both are intersecting at 0, comma, -7. So solution for this is, so is x is equal to 0 and y is equal to -7, and by graph there is a unique solution. So this is a unique solution. That means the given pair of equations are consistent. Okay, moving on to question number 22. For question number 22, we have to find some the length of xy, and in the figure is given that xz is parallel to BC. So xz is parallel to BC. So we can say that in triangle ABC, xz is parallel to BC. We are doing question number 22. So xz is parallel to BC, therefore by using BPT theorem, we get ax upon xb is equal to az upon zc. Now az is given, which is 3, and zc is given, which is 2. So ax upon xb is equal to 3 by 2. So this is 3 and this is 2, and this whole length is 5. That is AB is equal to 5. So AB is equal to AX plus XB, which is 3 plus 2 is equal to 5. Actually, these are the in proportions, but if we take them as a multiple of some constant 3x and 2x, so this will cancel out and still we will get the same value, 5x. Okay, now it's given that MC is 5 centimeter, the AZ is 3, ZC is 2, BM is 3. And we have to find the value of XY. So uh, now in this triangle, in triangle AXY, and let's say triangle is ABM. So in AXY and triangle ABM, angle A is equal to angle A. This angle is common. So this angle is common. And now, so angle A is equal to angle A is common, and angle AXY is equal to angle ABM because these are corresponding angles. So angle AXY is equal to angle ABM because these are corresponding angles. So AXY is equal to ABM, so that means the triangle AXY is similar to triangle ABM by a similarity. Okay, once these triangles are similar, so we can get the sides in proportion. So that means AX upon AB is equal to xy upon bm. Let's put in the values. So ax is 3 and ab is 5. Xy, we have to find out xy. And next one is bm. So bm is given, it's 3. So bm is 3. So xy is equal to 3 into 3 divided by 5, which is equal to 9 by 5. And this is equal to, it's 5 over 5, 1.8. So this is 1.8 centimeter. Okay. So this is 1.8 centimeter. And let's move on to question number 23. So for question number 23, okay, it's given that sine theta plus cos theta is equal to 3 root 3, and we have to find the value of sine theta into cos theta. So it's given that sine theta plus cos theta is equal to root 3. Now squaring on both sides will give us sine theta into cos theta. So squaring on both sides is sine theta plus cos theta the whole square is equal to the root 3 the whole square. So this gets cancelled, and this is now sine square theta plus cos square theta plus 2 sine theta into cos theta is equal to 3. Now sine square theta plus cos theta is 1. So this is 1 plus 2 sine theta into cos theta is equal to 3. So this is 2 sine theta into cos theta. 3 minus 1 is 2. 2 and 2 gets cancelled. So we are left with 1. So sine theta into cos theta is 1. 6. It did. It's the division that we did for 2 and 2. So it's 1. Okay, so next one is option B, where it's given that sine alpha is equal to 1 by root 2 and cot beta is equal to root 3. We have to find the value of cosecant alpha plus cosecant beta. So for part B, it's given sine alpha is equal to 1 by root. So sine alpha is 1 by root 2. That means cosecant alpha is root 2. Okay, now cot beta is root 3. So cot beta is root 3. And we know that 1 plus cot square beta will give us cosecant square beta. Let's put the value of cot beta, which is root 3 the whole square, is equal to cosecant square beta. So this is 1 plus 4. Okay, so this is 1, sorry, 1 plus 3 is 4. So this is 4 is equal to cosecant square beta, and cosecant beta is equal to root of 4, which is equal to root 2. So if we have to add them, so cosecant alpha is root 2 and cosecant beta is 2. So answer is 2 plus 2. So cosecant alpha plus cosecant beta is equal to 2 plus 2. Okay, this solves our part B. Okay, for question number 24, we have to find the greatest number which divides 85 and 75, leaving remainder 1 and 2. So 1 and 2 has to be the remainder for 85 and 72. So let's subtract 1 from 85, which is 84, and subtracts 2 from 72, which is 70. This is question number 24. Now let's find the HCF of, so HCF of 84 and 70, we would have to find out, so that we can get the greatest number which will divide 85, which will divide 84, but will remain leave remainder 1 in this case, which will divide 40, but for 72 it will leave remainder 2. So 84 is, if we factorize, this is 221 and 3 into 7. This is 2 square into 3 into 7. And 70 is divided by 2 is 35 and 7 5 are 35 is 2 into 7 into 5. So this is 7 and among them. So HCF is equal to 2 into 7. So between 2 square and 2. Smallest is 2 and common in 7 and 7 is 7. So HCF is 14. So 14 is the greatest number which divides 85 inside 2, giving me 1 and 2 in each case. 25th is an easy one. The bag contains 4 red, 3 blue, and 2 yellow balls. So total balls are 4 plus 3 plus 2, which is 9. Okay. So total balls in this case are 4 plus 3 plus 2 is equal to 9. And let's clear this. Okay, so we have to find the probability that drawn ball is red. So probability of red ball is equal to number of red balls are 4, total balls are 9, so this is 4 by 9. And we have to find the probability of the yellow, so yellow balls are 2 and total balls are 9, so this is the required probability. Let's move on to the next page. Okay, for the next page is section C. So we are on section C, and this section comprises of short answer type questions of 3 marks each. Let's move on to the first one, 26. And it's given that the half of the difference between two numbers is 2. So let the greatest number be x and smaller number be y. Okay, so now according to the question, the difference between the two numbers is 2. So small greater minus smaller is equal to 2. And now the sum of the greater number, that is the greater number sum with y is the smaller number is equal to 13. These are the two equations, and we can directly subtract them to get the value of y. So this gets cancelled, and minus 3y is equal to minus 13 minus 2 is 11. So this gets cancelled. So this was x minus y is equal to 2, and sum of the greater plus twice the smaller number is 13. So if we subtract them, this gives us negative 3y is equal to 13 minus 2 is 11. This is negative 11. And we have to find the numbers. So let's find out the value of the sum of the greater number and twice the smaller number. Greater and twice the smaller number. The difference of them, if half of the difference it's given, sorry. So let me just write down this equations once again. So it's given that half of the difference between two numbers is 2. Read the question very carefully. So x minus y, that is the difference, and its half is 2. So that gives x minus y is equal to 4. This is equation 1. And now the greater number plus twice of the smaller number is 13. And we can directly subtract these equations, which gives us minus 3y is equal to minus 13. 13 minus 4 is 9, so this is negative 9, and y is equal to 3. So y is equal to 3, and from 1 we can get the value of x. So x minus y is equal to 4, y is equal to 3, so x minus 3 is equal to 4, which gives x is equal to 7. So our two numbers are x is equal to 7 and y is equal to 3. So we are done with the 26th question. And let's move on to the 27th, which we have to prove that root 5 is an irrational number, which obviously is an irrational number, but we have to prove it. And for that, we are going to assume that it's not an irrational, but it's a rational. Okay, for question number 27, let's say that root 5 is an rational number. So let's say it's a rational number. So let's say root 5 is uh, a rational. So let's give it a rational form. Let's say root 5 is equal to P by Q, where P and Q are co-primes. So by co-primes means that they have no other cofactor except 1. So they are not divisible by any other number. P and Q are co-primes. Now let's cross multiply this, which gives us root 5 into Q is equal to P. And if we square on both sides, so square on both sides gives us 5Q square is equal to P square. So if 5Q square is equal to P square, so that means 5 divides P square. And if 5 divides P square means 5 divides, and if 5 divides P, so if 5 divides P, let's say the quotient is C and remainder is 0. So the dividend P, now this implies we can write P as P is equal to 5 into C. So P is 5 into C, and if we replace the value of 2 in 1 we get. So P is equal to 5 into C, this is 5. And if we put 2 in 1, we get, if we put 2, that is the value of P in 1, we get 5Q square is equal to P is 5C the whole square, which means 5Q square is equal to 25, C square, 5 5 that is 25. So Q square is equal to 5C square, and this implies, what is the meaning of this? This implies that 5 divides Q square. So if 5 divides Q square means 5 divides Q. Now 5 is dividing both Q and both P. So that means P and Q are not co-primes because 5 is also dividing them. So that means but we have assumed in the beginning that P and Q are co-primes. So that means our assumption is wrong. So our assumption is wrong. Hence, root 5 is irrational. Okay, so this proves that root 5 is irrational. Let's move on to the question number 28. So let me erase this and move on to question number 28. So for question number 28, it's given that if negative 5, 3 and 5, 3 are two vertices of an equilateral triangle. So let's draw our plane. So let's say this is our plane and this is X and this is Y. So negative 5, 3 and 5, 3 are two vertices of an equilateral triangle. This is 0, 1, 2, 3, minus 1, minus 2, minus 3. And it's given that it's negative 5. So negative 4, let's say negative 5. So we have some negative 5, comma 3 here. And 5 comma 3 will be the first quadrant, let's say here. So if we join them now, then find the coordinates of the third vertex given that the origin lies inside the triangle. So this is our equilateral triangle, let's say with vertices A, B, and C. And C, we have to find out what are the coordinates of C. So because it's an equilateral triangle, so that means AB is equal to BC is equal to AC. So it is an equilateral triangle. And for the third vertex, we have assumed that the coordinates are x comma y. So that means AB is equal to BC is equal to AC. Okay, we can easily find out AB. So let's find out AB. So using the distance formula, AB is 5 minus of minus 5. So this is 5 minus of minus 5, the whole square plus 3 minus 3, the whole square, which gives us 5 plus 5 is 10 square plus 0, which is 10. So AB is 10. So AB is 10, and let's equate BC and AC. So if I create BC and AC, so BC is, this is 5 minus x, or x minus 5 the whole square, whatever it is. So it is x minus 5 the whole square plus this is y minus 3 the whole square, and AC. AC is x minus of minus 5 the whole square plus y minus 3, y minus 3 the whole square. And this whole thing is under root. So under root and root gets cancelled if we square them. So now we have, this is x minus 5 the whole square means a plus b the whole square. So a square plus b square minus 2ab is minus 10x. This is a square plus b square minus 2ab minus 6x. This is x plus 5 now, which is a square plus b square plus 10x plus this is a square plus b square and minus 2ab, which is minus 6y. So x squared gets cancelled, 25 gets cancelled, y square gets cancelled, and 10x, this should be actually minus 6y, this gets cancelled. Now minus 10x and 10x, and we have 9 and 9 gets cancelled, so it's minus 20x is equal to 0. So this gives us x is equal to 0. So x is equal to 0, we can find out. Now let's find out y, and for that let's equate BC to 10. So let's say BC is equal to 10. So this is BC, which is x. So BC square is equal to 10. So that means BC square should be equal to 100. And it's x minus 5 the whole square, BC square plus y minus 3 the whole square is equal to 100. Okay, x is 0, so this is minus 5 square is 25, and this is y minus 3 the whole square is equal to 100, and which gives us y minus 3 the whole square is equal to 100 minus 25, which is equal to 75, and y minus 3 is equal to root of 10 to 75, which will give us the value. So 75 is 15 into 5, and 15, so root 75, 15 is 3 into 5 into 5, which gives us plus minus 5 root 3. Okay, now we have two values, plus minus 5 root 3, because this is in the, this lies, I think, because the x is 0, so that means this lies on the y-axis, so x is 0, and this is the negative value of y, so we will just consider the negative value here. So I'm going to raise this, and this is now negative because it's on the negative y-axis, so y is negative 5 root 3, and when 3 is shifted here, this is plus, so y is equal to negative 5 root 3 plus 3, and value of root 3 is 1.7, which gives me 7 5s are 35. So 17 into 5 is 7 5 are 35. 8 is negative 8.5 plus 3, which gives negative 5.5. So the coordinates y is negative 5.5 and x is 0. So our coordinate, the third coordinate, this one is 0 comma negative 5.5. Okay, this solves our question number 28, and let's move on to question number 29, first part. So let me erase all of these. Okay, so uh, for question number 29, we have to prove that the two tangents uh, TP and TQ are drawn to a circle with center rho from an external point. We have to prove that PTQ. So for question number 29, now this OP is perpendicular to PT because radius is perpendicular to tangent at point of contact. So OP is perpendicular to PT at tangent of point of contact. So that means angle OPT is equal to 90 and angle OPT is 90. Angle OPT is comprised of OPQ and TPQ. So I can write it as OPQ plus angle TPQ is equal to 90 degree. Okay, so this gives me angle TPQ is equal to 90 minus angle OPQ. Okay, let's keep this as equation 1. Now PT is equal to TQ because tangents drawn from an external point to a circle are equal. So that if the tangents are equal, so then they're up it's in the triangle PTQ. So that means angle PQT or TPQ. So if these tangents are equal, that means angle TPQ is equal to angle TQP. And this is because angles operate to equal sides are equal. So let's use the angle sum property in this triangle. So in triangle TPQ, so in triangle TPQ, angle TPQ plus angle TPQ plus angle PQT, TPQ plus angle PQT plus PTQ plus angle PTQ is equal to 180 degree. This is the angle sum property of a triangle. Now TPQ and TQP are equal. So TPQ and this is angle TPQ and PQT are equal. So for both of them, I can write angle TPQ. So instead of PQT, I can write TPQ. So this is PQT. Instead of PQT, I can write TPQ. So this is TPQ plus angle PPQ plus angle PTQ is equal to 180 degree. And this is 2 times angle TPQ plus angle PTQ is equal to 180. Now angle TPQ. So we have this angle TPQ is equal to 90 minus OPQ from 1. So I can write 2 times angle TPQ is 90 minus angle OPQ plus angle PTQ is equal to 180 degree. So if I open up the bracket, this is 180 minus 2 times angle OPQ plus angle PTQ is equal to 180. So 180 and 180 gets cancelled, so minus 2 times angle OPQ is equal to negative of angle PTQ. This gets cancelled. And finally, we have angle OPQ, 2 times angle OPQ. So this is PTQ. So finally, we have PTQ is equal to 2 times angle OPQ. So PTQ is equal to 2 times angle OPQ. And this solves our question number 29's first part. And let's move on to the second one. Okay, so uh, we have done the first part of the question number 29, and let's move on to the second part of question number 29. And for second part, it's given that there is a circle that is described in a quadrilateral ABCD. So let me raise this first of all. Okay, so this is the circle that's inscribed in a quadrilateral ABCD, and we've given that angle B is equal to 90 degrees. So angle B is 90 degree, and it's given. I'm going to label it itself in the paper. So angle B, this is 90 degrees, sorry, and AD, length of AD is 17 centimeter, and AB is equal to 20. So AB is equal to 20 centimeter. And it's given that ds, so this is the length ds, which is 3 centimeter. We have to find the radius. We have to find the radius of the circle. Okay, now this ds and dr, it's equal. So ds is equal to dr, as these are tangents drawn from the external point D. So we can say that the reason is tangents drawn from external point to a circle are equal. And we know the value of ds, so that means dr is equal to, so it's given that ds is equal to 3 centimeters, so that means dr is also equal to 3 centimeters. Okay, now dr is also 3 centimeters, so we can get ar. So now ar can be, we can find ar by subtracting dr from AD. So it's AD minus dr. So AD minus dr. So this is dr and AD. AD, this is AD minus dr. AD is given at 17 minus dr is 3, which is equal to 14 centimeter. So AR is equal to 14 centimeter. Now AR is equal to AQ. These are also the tangents drawn from an external point to a circle. So AR is equal to AQ is equal to 14 centimeter, as the reason is same. Tangents drawn from external point to a circle are equal. Okay, now AQ is 14. We can get BQ because, so BQ is equal to, it's 20 minus 14 is equal to 6 centimeter. So we have got BQ is equal to 6 centimeter. Now BQ is equal to BP. Okay, this quadrilateral, in quadrilateral, so this is the quadrilateral OPBQ. So OPBQ. In quadrilateral OPBQ, angle P is equal to angle Q. These are all 90 degree. So angle P is equal to Q is equal to 90 degree as radius is perpendicular to tangent at point of contact. Right. Now angle B is equal to 90 degrees given. So by angle sum property, we can also show that angle O is also, so this angle O is also equal to, sorry, it's O. So this is angle O, and we can get that by subtracting this 90 angle P plus angle Q plus angle B, which is 270. So this is equal to 90 degree. We have used the angle sum property of quadrilateral. So that means quadrilateral OPBQ, and in quadrilateral OPBQ, PQ is equal to BQ. So we have this, all the angles in this quadrilateral OPBQ are 90 degree and two of its sides are equal. So that means OPBQ. So quadrilateral OPBQ is a square. So quadrilateral OPBQ is a square. You can also write that in quadrilateral OPBQ, we also have PB is equal to BQ. So PB is also equal to BQ because these are tangents drawn from an external point to a circle. So same reason, tangents drawn from external point to a circle are equal. Now in this quadrilateral, vertical sides are equal and all the angles are 90 degrees. So that means this is a square. And if it's a square, that means all of its sides are equal. So OP is equal to PB is equal to BQ is equal to OQ. All are equal. And if all are equal, so we have this BQ is equal to 6. So that means all sides are 6 centimeter and radius is also equal to 6 centimeter because two of these sides are the radius of the circle, OP and OQ. So radius of the circle is 6 centimeter. And let's move on to question number 30. Okay, so let's try to solve the question number 30, which is we have to prove that the given trigonometric identity, we have to prove the given trigonometric identity and okay, so we have this given trigonometric identity. We have to prove that tan theta plus secant theta minus 1 upon tan theta minus secant theta plus 1 is equal to 1 plus sin theta upon cos theta. So so let's consider RHS. So it's given RHS is tan plus secant. So it's tan plus secant theta minus 1 upon tan theta minus secant theta plus 1. Okay, and there is a relation because this is in terms of tan and secant. So we know that 1 plus tan squared theta is equal to secant squared theta, and that will give us 1 is equal to secant squared theta minus tan squared theta. So this is now tan theta plus secant theta minus 1 is, instead of 1 we can put in the value of 1, which is secant squared theta minus tan squared theta. Okay, and denominator is tan theta minus secant theta plus 1. Okay, so this is now tan theta plus secant theta minus, and this is a square minus b square, which gives us this is a minus b into a plus b, tan theta minus secant theta plus 1. Okay, now in this case, we have the common here is tan theta plus secant theta. So let me take this common, which gives me tan theta plus secant theta is common because this is one term and this is the second term in the numerator, and tan theta plus secant theta is common. So this leaves here 1 minus tan theta plus secant theta is common. So this is now, if I open up the bracket, my 1 minus secant theta. Okay. This is tan theta minus secant theta 1. If I open up the bracket, this is 1 minus secant theta plus tan theta upon tan theta. So, okay. An error here. So we have taken tan theta plus secant theta common, and which will leave us with, so this is tan theta plus secant theta is common. So this will leave us with 1 minus sec. This is 1 minus secant theta plus tan theta upon tan theta minus secant theta plus 1. And now this is, these two terms are similar, same, equal. We can cancel that. And now we are only left with tan theta plus secant theta. And we know that tan is sine by cos theta and secant is 1 by cos theta. So this is now equal to a particular LCM, which is 1 plus sine theta by cos theta, which is equal to RHS, and hence we have proved the identity. Okay, let's move on to the next question, question number 31. So we are going to solve question number 31, both the parts A and B. And A part says that a room is in the form of a cylinder surmounted by a hemisphere. The base radius of hemisphere is one half of the radius of the cylindrical part. So let's try to draw its rough sketch. So the room is in the form of a cylinder with a hemispherical dome at the top. Okay, now, so that means that now the base radius of hemisphere, this is the base radius of the hemisphere is one half of the height of the cylindrical part. So let's say the height of the cylindrical part is h. So base radius is half of the height, which gives us height is equal to 2 times r. Okay, so the base radius and the radius of the cylinder is same because it's surmounted on the hemisphere is surmounted on the cylinder. We have to find the total height of the room. So total height of the room is equal to, so what will be the total height of the room? So this is the room and its total height is radius, that is height of the hemisphere, which is the radius. So this is the height of the hemisphere, which is the radius. and the height of the cylinder, which is h. So total height of the room is h plus r, and that's what we are going to find out here. Now to find that, it's given that pi should be 22 by 7, and the volume of air in the room. So volume of air in the room is the volume of cylinder plus volume of hemisphere. So I can write down here volume of air in room is equal to 1408. So this is 1408 by 21 meter cube. Now volume of air in the room is the volume of hemisphere, which is 2 by 3 pi r cube, plus volume of cylinder, which is pi r square h. And this is equal to 1408 by 21 meter cube. Okay, now it's given that height is equal to 2r. So height is equal to 2r. We can write here 2 by 3 pi r cube plus pi r square h into 2r, which is equal to 1408 by 21 meter cube. Okay, so in this is now 2 by 3 pi r cube, and this is 2 pi r cube, which is equal to 1408 by 21 meter cube. Now, okay, this is 2 pi r cube, and this is pi r square h. So this is 2 pi r cube. Okay, and so r pi r cube is common, so pi r cube is common, and we are now left with 2 by 3 plus 2, which is equal to 1408 by 21. And 2 by 3 plus 2 is, it gives us, this is pi into r cube, and this is 3, 2 plus 6, which is 8 by 3. So this is 1408 by 21. And finally, r pi cube, this is 8 by 3. And r cube is equal to 1408 by 21 into 3 by 8. And pi becomes 7 by 22 this side. Again, if we try to solve this, this is 3 7 are 21, 7 and 7 gets cancelled. This is 2 4s are 8, and 704 again cancelled with 2. So this is 352. And again, if we cancel this with 2, so this is 2 1s are 2, and 2 7s are 14, 2 6 are 12. So this gets cancelled with 11, 2 are 22, 11 1s are 11, and 11 6 are 66, and 2 with 8. So r cube is equal to 8. So that gives r is equal to 2 meter. So radius is 2 meter, and height is double of the radius. So height is equal to 2 into r, which is equal to 4 meter, and total height. Now the radius is 2, height is 4, so total height of the room is 4 plus 2, that is equal to 6 meter. Okay, now let's also try to solve the part B of this question. And for this, let me erase this. And let's try to understand what is given in the part B. So part B says that there is an empty cone which is of radius 3 centimeter and height 12 centimeter. So empty cone is of height 12 centimeter. So the height is 12 centimeter. So the height is 12 centimeter. And the radius is 3 centimeter. Okay. So this is an empty cone, and ice cream is filled in it. So ice cream is filled in it so that the lower part of the cone, so this is the lower part of the cone, So which is 1/6 of the volume of the cone is unfilled. So that means the ice is not in the lower part, it just remains in somewhere in the upper part of the cone. This is where the ice cream is, and but also the hemisphere is formed on the top. So okay, this is the ice cream. So this is where the ice cream is. So the lower part of the cone, this part, it remains unfilled, and ice is just only in the hemisphere and the upper part of the cone, and we have to find the volume of the ice cream. Okay, for we can find the volume of the ice cream where it has formed the hemisphere. So volume of ice cream in the hemisphere. So hemisphere's volume is 2 by 3 pi r cubed, and radius is 3 centimeters. So this is 2 by 3 into pi into this is r cube is radius is 7. So radius is 3 and the cube of 3 is 27. So this is 2 by 3 into pi into 27 and 9 3 is 27. So this is 18 pi centimeter cube. Let's leave it here. Now let's move on to where the volume. So this part is 1/6 of the volume of the cone. If this part is 1/6, so that means this part is the whole is 1. This is the 1, and this part is 1 minus 1 by 6 is equal to 5 by 6. That is, the ice cream is in 5 by 6 part of the volume of the cone. So volume of ice cream in upper part, because lower part is unfilled, upper part, and that is of cone. So upper part, it is 5/6 of the volume. If the lower part is 1/6, the upper part is 5/6. So this is 5/6 of the volume of cone, and volume of cone is 1 by 3 pi r square h. So this is 5 by 6 into 1 by 3 into pi, radius is 3, so 3 square is 9, height is 12. So this is 3 3 the 9, 3 2 are 6, 2 6 are, this is 30 pi centimeter cube. Now, total volume of ice cream in cone. So total volume of ice cream is cone is just the sum of ice cream in the hemisphere, which is 18 pi, plus the sum of this ice cream in the upper part of the cone, which is 13 pi. So which is 48 pi centimeter cube. And now this is 48 into 3.14. So 48 into 3.14. If we calculate this, this will give me 150.72 centimeter cube. So this solves our question number 31, and let's move on to question number 32. For question number 32, section D, and this section comprises of long answer questions of 5 marks each. And the first one is, if a line is drawn parallel to one side of a triangle to intersect the other two sides at distinct points, prove that the other two sides are divided in the same ratio. This is the BPT theorem, and we have to prove this. So let me draw a triangle. Let's say this is our triangle, and it's given that a line is drawn parallel to one side of the triangle. So let's say to intersect the other two sides in two distinct points. So these are the two. Okay, so this is the triangle, and line is drawn to intersect the two sides in points D and E. And so what is given is DE is parallel to BC, and we have to prove that the ratio of the corresponding parts of the sides, that is divided by DE, are divided in the same ratio, that is AD by DB is equal to AE by DC. That's what we have to prove. And for this, let's do some construction. And the construction is that we are going to draw DN or DN and EM perpendicular to AB. So this is EM. So construction is draw EM perpendicular to AB and DN perpendicular to AC. So, and also let's join D to C and B to E. And we have to prove now. So we have joined this. Okay, now let's find out the area of triangle ADE, ratio of area of triangle ADE and ratio of area of triangle BDE. So triangle ADE, for triangle ADE, if I take base as AD, so half into base and height is EM. For triangle BED, if I take base BE. Okay, now triangle BDE is an obtuse angle triangle. So this is an obtuse angle. So its height is outside, which is perpendicular to the side when produced. So BD is an obtuse angle triangle at D, and its height is EM, which is outside the triangle. So this is also EM. So EM, half gets cancelled, and now it's equal to AD by PD. Let's say this is our first set of equation. Similarly, I'm once again going to find out the ratio of area of triangle ADE, and this time it has to be the triangle DEC. Now ADE, this time I'm going to find the area of the triangle ADE by taking base AE and height is EM upon half into, for triangle DEC, base is EC and it's also an obtuse angle triangle. So for obtuse angle triangle, so if this is an obtuse angled triangle, so its height is outside. So for this, the height is, for obtuse angle triangle, this obtuse angle at A height is dn. So this is, okay, for AE, if base is AE, height should be dn, and for triangle DAC, it's AC half into EC into dn. So dn and half gets cancelled. So this is equal to A by AC. This is our second set equation. So we have almost got the result if these RHS are equal, but here it's AD and AD. So instead of these are making the difference, and if we are able to prove that these two are equals and these two sides will be equal, and we will get our result. Now triangle BDE. So this is the triangle BDE and this is the other triangle DEC, and these are on the same base DE, and DE is parallel to BC. And we know that in earlier classes, we have studied that the two triangles on the same base, these are the triangles on the same base DE. This triangle, BD, BDE and DEC, they are on the same base DE and between the same parallels. So if triangles are between the same parallels and on the same base, then they are equal. So equal in area. So that means area of triangle BDE is equal to area of triangle DEC. This is the triangle because these triangles are on same base and the base is DE and parallel same base DE and same parallels DE and EC, and we know that the area of such triangles are equal. So now let's So this DEC will be replaced by BDE, and once it's replaced by BDE, we will get our LHS equal. This will make RHS equal. So instead of just writing this, we can just write from 1, 2, and 3 AD upon BD is equal to A by C, and this proves our BPT theorem. Okay, now let's move on to question number 33, which has two parts. For question number 33, we are going to solve the first part, and it's given that the angle of elevation of the top of a tower 24-meter high from the foot of another tower in the same plane is 60 degree. Okay, so there is a tower 24-meter high. So let's say this is the tower, which is 24-meter high, and its angle of elevation from another tower in the same plane is 60 degrees. So let's say here is another tower, and from here the angle of elevation to its top. So angle of elevation to its top is 60 degree. Now, so this is the height of the tower. Height of the tower is 24-meter. Okay, now there's another tower in the same plane. The angle of elevation of the top of second tower. So this is the foot of the second tower, and the angle of elevation to the top of second tower from the foot of first tower. So from the foot of the first tower, the angle of elevation to the top of second tower is 30 degrees. So it's 30 degrees. That means the height of the second tower is it's shorter than the first one because its angle of elevation is 30 degrees. So this is the angle of elevation. This is 30 degree. It's 30 degree. And we don't know the height of this tower. So the distance find we have to find the distance between the two towers and the height of the other tower. So we have to find the height of the other tower, also find the length of the wire attached to the top of the two towers. So let's find them one by one. So let me just label them. This is A, B, C, and D. So B is AB be the height of second tower, and DC be the height of first tower. So it's given that DCB. So let DC is equal to 24-meter be height of first tower, and AB be height of second tower. Now we have to find the height of AB. We have to find AB, and we have to find BC. That is the distance between the two towers. Okay, so for in right angle triangle, because these poles are standing vertically on the ground, so they are making an angle of 90 degree with the ground, so it's vertical. And let's first uh, from the right angle the triangle. So this is right angle triangle BCD. If we use tan 60 will give us DC by BC, and DC is 24, which will give us BC. Now tan 60 is root 3. So tan 60 is root 3. This is 24 by BC, and if we cross multiply this gives us BC is equal to 24 by root 3 into, if I rationalize this gives me 24 root 3 by 3. This is 3 8 are 24, which is 8 root 3 meter. Okay, so the distance between the towers is 8 root 3 meter, and we can write that distance between towers is equal to 8 into root 3 meter. Okay, now let's find the height of the second tower. So we have got BC, which is 8 root 3 meter. Now we can use the tan ratio in right angle triangle, that is ABC, which is tan 30. So tan 30 is equal to AB by BC. Now AB tan 30 is 1 by root 3 AB, and BC is 8 root 3 root 3 gets cancelled, which gives us, this gives us AB is equal to 8 meters. So height of second tower is 8 meter and distance between two towers is 8 root 3 meter. Okay. Now, if you read further, it says that we have to find the length of the wire tied to the top of two towers. So let us join the two towers. So we have to now find AD. So we have to find AD, that is the length of the wire attached to the top of the two towers. And for that, let's uh, draw this perpendicular from A to DC. Let's say this is E. Now AB is 8 meter. So AB is equal to EC is equal to 8 meter. So this is also 8 meter, and which gives us DE is equal to 24 minus 8 is equal to 16 meter, and BC, this BC is equal to AE is equal to 8 root 3 meter. And now in this right angle triangle, that is AED, we can use the Pythagoras theorem. So I can say in right angle triangle AED, AD square, that is what we have to find out, the length of the wire joining the two tops of the towers, and AD square is equal to AC square plus DE square. And how do we get this result? It's using Pythagoras theorem. So let's put in the values. So AD square, AE is 8 the whole square, and DE is 16 square. So this is 8, 8 are 64, 3 into 192, and 16 square is 196. So, okay, so 16 square, this is 192, and 16 square. So if we square of 16 is 96 into 16, which is 256. And this is now 8, 9, 5, 14, 2 and 3 and 4. So this is AD square, and AD is equal to under root 448. And if we factorize 448, so this gives us, if we factorize 448, this is 2 into 4, 2, 1, 1, 2, 2, 5, 6, and 2 to the 4, 18, 2, 14, and 2, 7. So this will give us, these are in pairs, so it's 2. So this is now equal to 2 into 2 into 2 into 2 into 2 into 2 into 7. So these are in pairs, and I have written an extra here. Okay, so this is into 7, which gives us 2 into 2 into 2 into 7. So 2 to the 4, 4 to the 8, and 8 7 that is, okay, so it's not, this 7 is under root, still in the root. So 2 to the 4, 4 to the 8, and this is now 8 root 7 meter. And this solves our question number 33's first part. Let's move on to the part B. For the part B of question number 33, it's given that a spherical balloon of radius r subtends an angle of 60 degree at the eye of an observer. So let's see how is the spherical balloon going to subtend an angle of 60 degree at the eye of the observer. And let's get our spherical balloon first. Okay, let's say this is the spherical balloon, and so this spherical balloon is going to subtend an angle of 60 degree at the eye of the observer. Okay, let let's say our observer is here B, and this is the eye of the observer. So how is this balloon going to subtend an angle of 60 degree at the eye of the observer? So we have to take two diametrically opposite ends of the balloon, and so this is how the balloon is going to make an angle of 60 degree. So let's say this is okay. This is one tangent, and this is, let's say, another tangent from the balloon, and this is the 60 degree subtended, and let O be the center of the balloon, spherical balloon. So this is how the angle has been subtended by the balloon at the eyes of the observer 60 degree. And let's say this is our horizontal at the level of the observer's eye. Now, height of the balloon from the ground is, let's say, this is the height of the balloon from the center, and this is, let's say, H. Let me just keep it as it is. Okay, I have moved. Okay, this is, okay, so this is the height of the balloon from the center, from the observer's eye. Now, it's also given that the angle of elevation at its center is 45 degree from the same point. From the same point means from the observer's eye, the angle of elevation is 45 degree. And now this angle of elevation is 45 degree from the center. From the center, so this is 45 degree. And this is our figure. Okay, now if I join this with the contact point here, so this is the radius. This is also the radius, and we know that radius is perpendicular to the tangent at the point of contact. So let me give these points P and B, and let's say this point is Q. So this point is Q, and I'm going to raise this. Okay, this is how this question is represented as a diagram. And we have to show that the height of the center of the balloon, that is this OQ. So OQ, we have to prove that it's root 2 times R. So let's say OQ is H, let height, let's say OQ is equal to H. So that means we have to prove that height of the balloon, height of the center of balloon is root 2 times its radius. So that's what we have to prove. Okay, now let's get if this is 60 degrees, so that means if this angle is 60 degrees, so these two triangles are congruent because these two are the radii of the same circle. These two are the tangents drawn from external point. This is common. So that means this angle is 30 degree. If these two triangles are congruent, so angle O B, let's say this is, I have given it B. So this is, let's say, Q, and this is R. Now OR, let's say this is OR. So OR is equal to H. Now angle OBQ is equal to 30 degree. And if you want, you can prove the triangle is congruent and then with the half of this angle, because this complete angle is 60 degree. Okay, now this angle is 90 degrees, so that means this is the hypotenuse, and for this angle, this is the perpendicular and this is the base. Now, you can also write that OQ is perpendicular to BQ. Why? Because radius is perpendicular to tangent at point of contact. Okay, now, so if this is 90 degrees, so that means in right angle triangle OBQ, I can use R by hypotenuse, perpendicular by hypotenuse sine. So this is sine 30 degree, which is R by OB, and sine 30 degree. So sine 30 degree is half, which is R by OB. And if we cross multiply this, this gives me OB is equal to 2R. Okay. Now let's move on to the right angle triangle. So this is also 90 degree because this is the distance is the perpendicular distance. So we can say in right angle the triangle ORB. So in right angle triangle ORB tan 45. So this is tan 45 degree is equal to OR by BR. The tan 45 is 1. Now OR is the height, and okay, we are not going to use tan 45 years. Let's see if we can get OB involved. So this is 90 degree, this is hypotenuse, H, this is H. So H for 45 degree, this is perpendicular by hypotenuse. So I'm going to use once again sine 45 degree, which is equal to H by OB. And sine 45 degree is 1 by root 2. This is H upon OB. If we cross multiply this, this gives me OB is equal to H into 2. Let's say this is equation 2. So from 1 and 2, we get from 1 and 2, we get 2R is equal to root 2 into H. And this gives H is equal to 2R by root 2 into root 2 by root 2, which gives 2 root 2R by 2. So pi is equal to root 2R. Okay, so that's what we have to do. Height from the center is equal to root 2 times the radius of the spherical balloon. And this solves our part B of the question number 33. Let's move on to question number 34. For question number 34, it's given that a chord of a circle of radius 14 centimeters subtends an angle of 60 degree at the center. So let's say if it's the circle and there's a chord of length 14 centimeter which subtends an angle of 60 degree at the center. So like this is the center of the circle, which is O, and angle is 60 degree. Now this subtends an angle of 60 degree, this chord, and okay, radius is 14 centimeter. We are not given with the length of the chord. It's not given. Okay. Now we have to find the area of the corresponding minor segment. So this is the minor segment. Okay. Now triangle AOB is an equilateral triangle because this angle is 60 degree and OA is equal to OB. These are the radii of the same circle, and angle opposite to these two equal sides in this triangle are also equal. So that means these two angles are also 60 degree and 60 degree. Now triangle AOB is an equilateral triangle, therefore area of triangle AOB is equal to root 3 by 4 into side square, which is 14 square centimeter square. Now, okay, so this is an triangle AOB is an equated triangle. The area of the triangle we have now the area of minus segment is area of sector minus area of triangle AOB. So let's find out the area of minus segment. So this is area of sector AOB minus area of triangle AOB. Okay, so area of sector AOB is theta by 360. Theta is 60 by 360 into pi into radius is 14 square. Area of triangle is root 3 by 4 into 14 square. So this gets cancelled 6 and this is 1 by 6 into 22 by 7 into 14 into 14 minus root 3 by 4 into 14 into 14. So 7 to the 14 to 3 are 6. And now 22 into 14. 4 to the 8 and 22 that is 308 and divide by 3 minus 14. This is I can write it as this is 2 to the 4, 2 7 the 14, 2 7 the 14 and this is 49 root 3. Okay, now it's not mentioned in the question anywhere the value of root 3, so it's up to me if I can want to put in the value of root 3 or not. I'm going to leave it just as it is. So this is the area of the corresponding minor segment. And let's find out the area of the major segment, which should be the area of circle minus area of minor segment. So area of major segment is equal to area of circle minus area of minor segment. So area of circle is pi r square, which is 14 square, and minor segment is 308 upon 3 minus 49 to 3. And 14 square is 196. So 14 square is 4 fours 16 5 and it's 5 into 196. Or let me just try to write down the value of pi, which is 22 by 7 into 14 into 14 minus 308 by 3 plus 49. 3 if I open up the bracket, so this is 7 to the 14. 22 into 2 is 44 and 44 into 14 is 4 4 16 4 4 16 17 and 44 6 11 616. This is 616 minus this is 308 by 3 plus 49 to 3 and let's take LCM here. So this is 3 and 6 3 there is 18, 3 on the 3 4 and 6 3 there is okay, so 616 into 3 6 3 there is 18, 3 on the 3 4 6 3 there is 18. This is 1848 minus 308 plus 49 root 3 centimeter square, and 8 minus 8 is 0, 4 minus 0 is 4, 8 minus 3 is 5, 1540 upon 3 plus 49 root 3 centimeter square is the area of the major segment. And let's move on to the question number 35 that has part A and B. For question number 35, we have to find it's given that the ratio of 11th term to 17th term 1.8 is 3:4. So let A and D, let A be first term and dB common difference of AP. Let us assume this difference of A and AP. Okay, now it's given that the ratio of 11th term to 17th term, that is 11th term is A11 and 17th term is A17, is equal to 3 to 4. Now A11 is A plus 10D and A17 is A plus 16D, 3 by 4. So A11, we have used the n formula, that is A plus n minus 1 into D, and we have got this. So if we cross multiply, we get 4a plus 40d is equal to 3a plus 48d. So this is a is equal to 8d. So a is equal to 8d, and we have to find the ratio of fifth to 21st term of the same a. So we have to find the ratio of fifth term to 21st term, and fifth term is a plus 4d, and 21st term is a plus 20d. Now a is 8d. So this is 8d plus 4d and 8d plus 20d. So this is 12d and 28d. D and D gets cancelled. 6, 14, 3, and 7. So the ratio is 3 is to 7 for the fifth and the 21st terms. Okay, now we have to find the sum of first five terms. So sum of first five terms to the ratio of first 21 terms. So sum of 21 terms we have to find. So let's use the formula for sum of n terms, which is n. So n is 5n by 2 into 2a plus n minus 1, which is 4d. This is 21 by 2 and 2a plus 21. That's 20d. 2 and 2 gets cancelled. So this is equal to 10a plus 5 fours are 20d, and this is now okay. So rather, let me just put in the value of a. So this is 5 into, and a is 8d. So a is 8d, so it's 2 into 8. If I put in the value of a from here, so this is 16d plus 4d upon 21 into, this is 2a, so 2 into 8 is 16d plus 20d. So which gives us 5 into 16 plus 4 is 20d. This is 21 into 16 plus 20 is 36d. D and D gets cancelled. So this is 5, 2, 10 are 20, it's 18, 5 and 9. And now this is 25 or 9 on the 9, and the ratio is 25 is to 189. So the ratio of first 5 terms to the ratio of first 21 terms is equal to 25 is to 189. This is our answer. And now let's move on to the B part of this. For part B, it's given that there are 25 logs that are stacked in the following manner. That is, there are rows of the lags, and in the bottom row there are 22 logs, and at the top, as we move towards the top, there is one log decreasing in each row. So it's given that number of logs in bottom row is equal to 22. Okay, now number of logs in row above, or let's say let us write it as let the number of rows be n, rows be n, and now the number of logs in each row 22, 21, 20 up to, let's say, n rows forms an AP. So that means if it's form an AP, A is equal to 22 and B is equal to 21 minus 22, which is equal to negative 1. Okay. Okay, say it's given that the total logs is 250. That means if we try to sum up the number of logs in each row, it will give me 250. And to sum up these rows in which are in AP, we are going to use the formula S of n, which is equal to n by 2 into 2a plus n minus 1 into d. So this is the total logs, and total logs are given, which is 250. We don't know the number of rows, so let it be n, and a is 22 plus n minus 1 into d is negative 1. So this is 250 is equal to n by 2 into 44, and this is negative n plus 1. And 250 is equal to n by 244 plus 1 is 45 minus n, which gives, if we try to simplify this is 250 into 2 is 500, which is 45n minus n square, and this gives us, this is n square minus 45n. This is n square 45n plus 500 is equal to 0. Now, if we try to factorize 500 and solve this quadratic equation, this is 250 to 125 and 5 to 25 and 5. So 2 to the 4, 4 5s are 20 and 25 would be the factors. So this is n square minus 20n minus 25n plus 500 is equal to 0. And if we take n common and 25 here, this is n minus 20 and minus 20. So n minus 25 into n minus 20 is equal to 0. Okay, so this gives n minus 25 is equal to 0, or n minus 20 is equal to 0. So this is n is equal to 25, or n is equal to 20. So now we cannot have two rows for these stack of logs. So either n is not 25 or n is not 20. And that will be when we try to get the number of, if let's say the number of rows is 25, so then that means in the 25th row we will have a plus 24 into d logs. So this is 25 plus 24 into negative 1. Okay, a is 22. So this is 24 minus 24, which is negative 2, which is not possible. So n is not equal to 25. And that means the number of rows are 20 and number of logs in top row. That is, we have got the number of rows and the number of logs are in the top row. The top row is 20th row, so this is a 20, and which is a plus 19d. This is 22. 19 into negative 1, this is 22 minus 19, which is equal to 3. Okay, and this is also our part B of question number 35. Let's move on to section E. For section E, and this is where we have three case study hot passage based questions, and each question is of 4 marks. So this is the first case study, question number 36, and it says that while designing the school yearbook, a teacher asked the student that the length and width of the particular photo is increased by x on each side. That is, the length is also increased by x and breadth is also increased by x. So you have to increase both length and breadth by equal amount or the unit. And it has to be increased such that the area is now the double what was it before. And we have to write an algebraic equation depicting the new information. So algebraic equation depicting the new information is, now the length is x plus 18 and the breadth is 12 plus 18. And if we multiply this, if we can multiply this, this will give us an area, but that area is now the double of what it was before. So before it was, area was 18 into 10 and now it's double. So this is the algebraic equation that uh, depicts the given information. And second, we have to write the corresponding quadratic equation. So the corresponding quadratic equation can be obtained by simplifying this. So this is x squared plus 18x plus 12x and 18 into 12. So 18 into 12 is it's 16, 36 and 18, 6. It's 216 and this is 2 into 18 into 12 is 216. So this gives us x squared plus this is 20, 18 plus 12 is 30. This is 30x plus 216 is equal to, this is 2 into 216, 6 to the 12, 3, 4, and this is x squared. This is now x squared plus 30x and plus 216 minus 432 is equal to 0, which gives us x squared plus 30x minus 12 minus 6 is 6 and 2 minus 1 is 1, 4 minus 2 is 2. This is x squared plus 30x minus 216 is the quadratic equation. And what should be the new dimension means of that large photo means we will have to solve this now. So our quadratic equation is x squared plus 30x minus 216 is equal to 0. This is our new quadratic equation. Okay. You know, we have to solve this quadratic equation, and for that we have to get the factors of 216. So this is 108, 254, and 227, and it's 3, 9, 3. So this is 2 to the 4, 4 to the 8, and 8 to the is 24, 3 to the 9. So this is 3, 3 to the 9, and 9 to the 18. So our factors are uh, is 30x minus 216. So which will give us the factors. So this is 36, 2 to the 4, 4 to the 8, and or we can 3 to the 9, and 9 fours are is 36 and 6. So this is x squared plus 36x minus 6x minus 216 is equal to 0, and x is common, so x plus 36 minus 6 is common, x plus 36 is equal to 0, which gives us x plus 36 is 0 or x minus 6 is 0, and x is equal to negative 36, which is not possible, so x is equal to 6. And let's get the new dimensions. So the new dimensions are, so the new dimensions are 18 plus 6 is 24, and 12 plus 6 is 18. So these are the new dimensions of the photo: 24 centimeter and 18 centimeter. Okay, let's also try to solve the odd part. Can any rational value of x make the new area equal to 226? So it's saying that our new area was x squared plus 30x minus 216 is equal to, can it be 220? So if 220 means, so can any rational value of x make the new area equal to 220? So it's given that it's not, it's x squared plus 30x plus 216. Actually, it's given that our new area, this was our new area. And can it be 220? So that means if they are saying, can x squared plus 30x plus 216 be equal to 220? Can any rational value of x will give us the value 220? So let's check. Let's make the quadratic equation, which is now, so 220 minus 216 is negative 4. And now this will give us a rational, any value of x will give us a rational value when we try to solve this. And for to solve this, b should be perfect square. Let's calculate b, which is b square minus 4ac. So b square is 30 square minus 4 into a into c is negative 4. So this is 900 plus 16, which is equal to 916. So 916 is not a perfect square. So if it's not a perfect square, so that means now we cannot use, this is the D, the formula, the quadratic formula to find the value of x. So x cannot be rational unless and until this D is perfect squares, because only then we will get it out of the square root. So 916 is not a perfect square, so that means we cannot have any value of x for which our area is equal to 1220 centimeter square. So this is the first case study. Let's move on to the second one. Okay, our next case study is question number 37, and it's given that the data about the India Meteorological Department observes the seasonal and annual rainfall every year in different subdivisions of our country, and it helps them to compare and analyze the results. And the given below is the table which shows the subdivision wise season rainfall, that is in millimeter in 2018. So it's given, the table is given. If it's a rainfall, it's class categorized as the class intervals and the number of subdivisions where we are getting these rainfalls. So based on the above information, we have to answer the following questions. We have to write the model class. Okay, and for the model class, we know that the model class is the one that has the highest frequency, and that's between rainfall is between 600 to 800, between for number of subdivisions, that is 7. So our model class is 600 to 800. Now we have to find the median of the given data. So for finding the median of the given data, let's me find out the cumulative frequency first. So these are the class intervals: 200 to 400, 400 to 600, 600 to 800, and 800 to 1000, 1000 to 1200, 1200 to 1400, and 1400 to 1600, 1600 to 1800. Okay, and the frequency in this case is given as 2, 4, 7, 4, 2, 3, 1, 1. We have to find the median, so let's find out the cumulative frequency. So cumulative frequency is 2, 2 plus 4 is 6, 6 plus 7 is 13, 13 plus 4 is 17, 2 is 19, 2 is 22, it's 23, and it's 24. So n by 2 is 12, and we get 12 after 6. So this is our median class. That is, our answer should lie between 600 and 800 for the median. And we know that the formula of median is L plus n by 2 minus cumulative frequency upon f into h. So n is the lower limit of the median class, which is 600, n by 2 is 12, and the cumulative frequency is the cumulative frequency of the class, that is before the median class, the previous to the median class, which is 6, and frequency is 7 of the median class, and h is the class size, which is 200. So which gives us 600 plus 12 minus 6 is 6 by 7 into 200. So this is now 600 plus 1200 by 7. And if we divide 1200 by 7, so this gives us, so rather take, let's take LCM. So this is LCM is 7 plus 4200 plus 1200, which is 5400 divided by 7 millimeter, and 5400 divided by 7 is, it's 7 sevens are 49, and 14 minus 9 is 50. So 7 sevens are 49, 10, 7 ones are 7, 30, 4s are 28, and 20. So we can write it as 771.4 millimeter, which is within our the class interval of the median class. So this is the correct one. And we have also to find the mean rainfall this season. So let's find out the mean rainfall. So for that, let me keep this class interval and take off these data. Okay. Now we are going to find out the mean rainfall in this season. So mean rainfall in this season can be calculated by any of the methods. Either you can use the direct or the step deviation or any of the methods. So let's try to find it out. Okay, to find the mean of the rainfall in this season, we are going to use the step division, or let me use the direct method. So class marks of this class is 200 plus 400 is 600 divided by 2 is 300. So this is 300, 300, 400 plus 600 is 1000 divided by 2 is 500. So 300, 500, and it is 700. So this is 700, 900, 1100, 1300, 1500, and 1700. And let's multiply the frequency with the class marks. So this gives me 600, and this is 5 fours are is 22,000, 7 sevens are 14,900, 9 fours are 3,600, this is 2,200, this is 3,900, this is 1,500 and 1,700. Let's try to, so for this sum of all these, the frequency is 24, so this is 24, the frequency, and let's try to add these. So this is 6 plus, this is, okay, 9, 6, 15, 6, 21, and 2 is 23, and 9 is 32, and 5, 32, and 5, 37, and 7 is 44. So this is 4. 4 plus 2 is 6. 6 plus 4 is 10. 3, 13, and 2, 15, and 3, 18, 19, and 20. So this is 20,400. This is sigma fi into xi, and mean is sigma fi into xi divided by sigma fi. So this is 20,400 divided by 24, which will give us, it's 12, 10, 6, 5, 1, 0, 0, and 6. 8 that is 48, 6, 5 that is 38, 50. So mean is 850. Okay, and there's one more part question here which says that if the subdivision having at least 1,000 millimeter of rainfall during monsoon is considered good rainfall subdivision. So at least 1,000 means greater than or less than 1,000 millimeter. That is the meaning of at least. So greater than 1,000 millimeter is greater than or equal to 1,000 millimeter. At least 1,000 millimeter. So we have equal to. So this has 1,000, but 1,000 is not included here because the upper limit is not included here. So upper limit is included in this, which is the lower limit. So these all have rainfall equal to 1,000 or greater than 2,000. So our answer for this having good rainfall subdivisions would be 2 plus 3 plus 1 plus 1. So 2 plus 3, 5, 6, and 7. 7 subdivisions will have good rainfall. So add them and 7 subdivisions, you will get the answer for part 3. And now let's move on to the next case study. Okay, for question number 38, it's given that in a discus throw event, so this athlete attempts to throw a discus and the athlete spins anti-clockwise. So in this anti-clockwise direction, it spins, and then if it releases at this point, the discus flows tangentially. And he spins like around 1.5 times to the circle and then releases the throw. And when released, the discus travels tangentially. So the trajectory of this is given here, where AB is once a tangent to a circle of radius 75 centimeter. O is the center of the circle, angle ABO is 30 degree, and PQ is parallel to OA. So PQ is parallel to OA, and we have to find the length of AB. Now, AB is tangent and OA is radius, so OA is perpendicular to AB as radius is perpendicular to tangent at the point of contact. Okay, now this is a right angle triangle. So in right angle triangle OAB, so we have to find the length of OAB, and for in right angle triangle OABH is a hypotenuse for 30 degree. This is perpendicular and this is base. So we have to find AB and we know OA. So we are going to use tan 30 ratio. So tan 30 is equal to OA by AB. Now tan 30 is 1 by root 3. OA is 75 and it's 8. So AB is equal to 75 into root. So this is the first one. Let's move on to the second one. We have to find the length of OB. So OB is in the same triangle, but it's the hypotenuse. So we know the perpendicular and the hypotenuse. So let's use it for the ratio sine. So sine 30 is equal to P by H. And perpendicular here is OA by OB. So this is OA by OB, and sine 30 is half. So this gives us OA is 75 by OB. So OB is equal to 75 into 2 is 150 centimeter. So we are done with first, and the second we have to find the length of the AP. Okay, now uh, we have to find the length of the AP, and we know we have find here OB. So we know the length of OB, which is 150 centimeter, and we know the length of OQ is a radius, so it's 75. And now we can get BQ. So we are trying to solve the third part. So BQ is actually OB minus OQ. So OB minus OQ, OB is 150 minus OQ is 75. So this is 75 centimeter. Okay, now, so if BQ is also 75, so these both are 75. Let me just erase this. So finally, we have got that this is also 75 OQ and BQ is also 75. So that means Q is midpoint. So Q is midpoint of OB. Okay. Now PQ is parallel to OA. So PQ is parallel to OA. So that will give us BQ by OQ. BQ by OQ. So BQ by OQ is equal to BP by PA. Is equal to BP by PA. Now we know BQ and is 75, OQ is 75. So this is BP by PA. This gets cancelled, and this gives us BP is equal to PA. So that means P is also midpoint of AB. So P is also midpoint of AB. And if P is midpoint of AB and we know the length of AB is 75 root 3, and we have to find AP. So AP is equal to, if P is midpoint, then AP is equal to half of AB because P is the midpoint. So this is 75 root 3 by 2. So PQ AP is equal to 75 root 3 by 2 centimeter. Okay, so we have solved AP. Find AP. Now find the length of PQ. We have to find the length of PQ. Okay, now if we have to find the length of PQ, this triangle BPQ is similar to triangle OAB. Why? Because angle A is equal to angle P. These are the corresponding angles. Because PQ is parallel to OA and angle B is equal to angle B. This is common. So that means by a similarity rule, we can write that by a similarity rule triangle. Let's write them in symbolic form. Triangle BPQ is similar to BP is A and so BA. Now if the triangles are similar, then the corresponding sides are equal. So I can write down BP by BA is equal to PQ by AO is equal to, so BP by BA, PQ by AO, and BQ by BO. So this is BQ by BO. So let's put in the values we have here. BP, we know the value of BP, which is BP is equal to PA, and it's 75 √3. So PQ, the value of PQ. So let me just erase this and keep this. So it's PQ. We have to find out, do we know the value of AO? Yes, 75. Do we know the value of BQ? Yes, it's BQ is 75. And do we know the value of BO? BO, yes, it's 150. So it's 75 to the 150, and the value of PQ is 75 by 2. So PQ is equal to 75 by 2. And this solves our question number 38. With this, we have done, we are done with the question paper, complete question paper, which is fully solved. So we are done with the first set 31-1, and in the next video we will try to solve the second subset of the set 1. Do like, share and subscribe. Thank you for watching.